Hey everyone! So today we are diving into something that if you're building with AI, you really need to know about: multi-agent systems. We're going to break down what they are, why you should care, and, this is the important part, how you can actually build your own effective team of AI specialists. So let's start with a question, especially for all you developers out there. Does this sound familiar? You've got this one single AI agent you've built. It's supposed to be powerful, right? But the more stuff you add, more tools, more knowledge, the more it just gets confused. It feels like it's completely overwhelmed, just drowning in all that complexity. And what does that actually look like? Well, there are some pretty clear warning signs. Maybe your agent has so many tools it starts making bad decisions, just picking the wrong one for the job. Or, it needs so much specialized info that its context window just balloons out of control. And you'll definitely see it struggle with those tricky, multi-step tasks. If any of that is hitting a little too close to home, don't worry, you are not alone, and trust me, there is a better way. And that better way, that solution, is to completely change how you think about the problem. You need to stop trying to build one single all-powerful genius agent. Instead, you need to start thinking like a great manager. Because instead of one overworked generalist, you're going to build a team of specialists. And that right there is the core idea behind multi-agent AI. So why do this? Why build a team? Well, it's incredibly powerful, and it really comes down to three huge benefits. First, context management. This is a big one. Each specialist agent only gets the exact info it needs for its job. No more bloated context windows. Second, you get distributed development. This is a game changer for big projects. Different teams can work on their own agents completely independently. And third, parallelization. I mean, this is just awesome. You can have multiple agents tackling different parts of a problem all at the same time. We're talking a massive speed boost. Okay, this brings us to what might be the single most important concept here: context engineering. Seriously, burn this phrase into your brain. It is the practice, really the art, of deciding precisely what information each agent gets to see. Getting this right, I mean, this is everything. It is the absolute key to a great multi-agent system. It's all about making sure the right specialist gets the right data at exactly the right time. All right, so we've covered the why. We get it. A team of specialists is the way to go. But how do you actually get them to work together? I mean, how do they collaborate effectively? That's where the architecture comes in. And lucky for us, there are a few established ways to do this. Think of these as the four main patterns in your multi-agent toolbox. And here they are, laid out for us. Let's walk through them. First up, you've got the subagents pattern. Think of this like a classic org chart. There's a main manager agent that delegates tasks to specialist subagents. And just look at all those stars. It's amazing for doing work in parallel and letting different teams build things separately. Then there's handoffs. This is more like an assembly line, where one agent does its job and then hands off control to the next agent. Next, we have skills. This one's a bit different. It's still a single agent, but it can load specialized knowledge or skills whenever it needs them. And finally, the router. This is like a traffic cop. It looks at the incoming request and directs it to whichever specialist is best for the job. Okay, so the theory is great, right? But what about the real world? How do these patterns actually perform when the rubber meets the road? Well, that's what we're going to find out. We're putting them head-to-head in a performance showdown. We'll run them through three super common scenarios and see how they stack up. And we'll measure their performance by looking at things like cost and latency, basically how many calls they have to make to the model. All right, scenario number one. We're starting simple. This is the one-shot request. The user asks for one single thing. For example, buy coffee. This is about as straightforward as it gets. A dedicated coffee agent should nail this, no problem. And boom, here are the results. Right away, you can see that handoffs, skills, and router are all tied for the most efficient, clocking in at just 3 model calls. Subagents is right behind them with 4. And that one extra call? Well, that's just the tiny price you pay for having that central manager agent coordinating everything. A little bit of overhead. Okay, on to scenario 2. Now things get a little more interesting. The user is in the same conversation, and they make the same request again. Buy coffee again. Now, this seems simple, but it's actually a fantastic test of how well each of these patterns can handle memory and remember what just happened. And whoa, look at this. This is where you see a huge difference. Check out handoffs and skills. They only needed 2 more calls for a total of 5. Why? Because they're stateful. They actually remembered the previous conversation. Meanwhile, sub-agents and router, they're stateless, so they had to start all over again from scratch, almost doubling their total calls. That is a massive 40 to 50% efficiency gain for the stateful patterns. Huge. Okay, time for the final boss battle, Scenario 3, the multi-domain request. This is where we really push the limits. The user asks something complex like compare Python, JavaScript, and Rust for web development. This is tough because the agent has to go out and consult 3 totally separate, really big knowledge bases to get the answer. And this slide tells a fascinating story about trade-offs. On one hand, subagents and router are our efficiency champions here. Just 5 model calls and around 9,000 tokens. How? Because they can research each language at the same time in parallel, keeping everything separate. But then look at skills. It has the fewest calls, only 3, but at what cost? A whopping 15,000 tokens. It had to cram all that documentation into one massive context window. And poor handoffs, it just can't keep up because it has to do everything one step at a time. Okay, deep breath. That was a lot of data to take in. So let's pull it all together. Let's synthesize this. Because at the end of the day, the only thing that matters is this question. How do you pick the right pattern for your project? And this table really is the perfect cheat sheet. Let's break it down one last time. If you're doing simple one-shot tasks, honestly, most of these will do the job just fine. But if you have conversations with repeat requests, you've got to go stateful. Handoffs and skills are your best friends there, way more efficient. And for those big, complex, multi-domain queries, well, if you can break the problem down and do things in parallel, the subagents and router patterns are the absolute undisputed kings of efficiency. So if there is only one thing you remember from all of this, please let it be this. The secret to success, the real key, isn't just about picking the right pattern from a chart. It's about practicing thoughtful context engineering. It all comes back to that. Carefully, deliberately managing what information each of your agents sees. That is the one thing that separates a truly brilliant system from a hopelessly chaotic one. And that really brings us to the big idea here. The future of AI, it isn't going to be about one single super smart AI. It's going to be about orchestrating incredible teams of specialized AIs that all work together. So I'll leave you with this question to think about. How are you going to build your team?